Yes guys, welcome back to Payment School. Today we are continuing with continuing to our first topic, that's Algebra 1. And for particularly today we are going to review the number system and algebraic expressions, under which we are going to look at evaluating surds of such, root A, applying root A, use of index form, collecting of like terms, expansion of brackets, solving linear equations, factorizing algebraic expressions, and use of division algorithm or method without calculator. So we are going to just basically be looking into review some questions of maybe what we looked at in our introductory work. So let's start off. Write the following in index form. Write the following in index form. Okay, let's say a x times x, okay, b 7 times 7 times 7, c we have 2x times 2x, d we have a times b times b. So when I have something like this, you need to know that now for this one we are dealing with index, we are reviewing index. Index simply refers to power, or the number of times or a parameter or a number multiplies itself. So if we check here, the power of x or the index of x will be the number of times x is multiplied. Like you can see here, x is multiplied twice. That means x is going to be to the power 2. So we are going to simply write that the index in index form, x is going to be x to power 2, or x squared. 7 has multiplied itself 7 times. Okay, so the index of 7 will become 7 to power 3. Now for this case, remember x is multiplying itself, but it has coefficients, or a coefficient of 2. 2x is multiplying itself twice, so that means the whole of 2x is going to be to the power 2, so that you have something like 2x squared. But 2 squared, that will now need 2. If you give each one its square, that means we are going to have 2 squared is 4, then x will remain x to the power 2, something like that. Then here we can see that we will be collecting basically like terms, but writing them in index form. So we have a multiplying itself twice, so that means we are going to have a to the power 2 multiplying b, also multiplying itself twice. In short, you can just write a squared b squared, or you can just write as ab squared, something like that. So I think that's enough. Let's check another group. Find the exact value of the following. Okay, a, we have root of 36 times root of 36. B, we have root of 4 times root of 4. C, we have root x multiplying root x. Now for this case, we are reviewing that. Remember what we said in under our introductory work when we were introducing surds. We had rules that show that if you multiplying if the root of the same number is multiplying itself, let me say root of 2 multiplying itself is the same as saying root of 2 times 2. Okay, it's the same as root of 2 squared. So that means which actually will become 2, because 2 squared, if you get the root, will become 2. So that means actually if you see any number multiplying itself, like the root of any number multiplying itself, it's always that number under the root. So for this case, we have root of a times root of a is going to be a. Okay, because now that means we are multiplying with this can be expressed as a times a, all under the same root, which is a squared, and the root of a squared is actually a. So that means if you're multiplying root of the same number, it's going to be that number under the root. Okay, so for the case of 4 also, you're going to have 4, rather than maybe considering this to be 2 and this to be 2, multiply themselves, or this to be 6 times 6, giving us 36. We can say now we have x, root of x times root of x will still be x, actually x under that. So now let's check another group. Let's review another group. Let us say by collecting like terms, let's simplify the following expressions. Simplify the following by collecting like terms. Okay, let us say that a is actually 2x plus 3x. Okay, now we have 2x plus 3x, so x 2 of x, then adding to 3 of x will simply be 5x, or you can just split. It's going to be this 2 plus 3 will be 5, then the x will always be, so 2 of x plus 3x will actually be 5x. That's a simple way I can say that. Find that will become 5x. We are just reviewing this. Another one, let's say 9x squared plus 3x squared, then minus 2x squared. Still they're of the same term. We don't have any collecting like terms there. We are just going to combine the x squared, just like here. Here we are basically testing collecting of like terms. So here we're going to see that we have all the terms are in x squared, so it's simply getting their coefficients will determine the coefficients of the final one, and you just attach x squared. So 9 plus 3 will be actually 12, minus 2 will be 10. So this one is actually going to be 10x squared. Okay, if you have another one, let me say 4xy plus 3, 4xy plus 3yx. Here you need to recognize that xy and yx are the same, because when numbers are multiplying themselves, 2 times 3 is the same as 3 times 2. So and it can, in the same sense, x times y is the same as y times x. Okay, so that means xy is actually the same as yx. Okay, so that means if you rearrange that, we are going to have something like 4xy, okay, plus 3. We arrange to also to make them appear alike. So that means 4 times 3, now it's the same term, xy. So we don't bother, we just add 4 and 3 to be give 7 of the same term xy. Okay, we check another one. Let us say D. Let us say we have 6 y minus 3y then plus 4x. Okay, here you need to realize the terms we have are y and x. We have 2 terms, so we just collect like ones. We collect y separately and x separately. So if you see for y, we have 6y minus 3y to remain 3y, then plus 4x. Those are the terms we have, and we have collected them. We have y separate and x separate. Now let's go to the last one. Let me say under that, say 2x squared minus 3x plus 4. Okay, here you realize that we have actually 2 terms, 3 terms. We have a squared, and we have a 3x, and we have square x squared. We have a x to power 1, then we have a constant of 4. So if you realize here we have 4 terms. So remember when we were introducing quadratics, these are quadratic equations, this is to the power 2. We can check whether this has factors. In case we can simplify, the simplest way we can simplify maybe would be to factorize, because now if you see that we have a sum of -3, but our product is going to be 8. And which two figures can we multiply to give us 8? But if you see add them, it will give us -3. Let us first check on a calculator. I gave that, and when we are looking at quadratics, we can first check in our calculator. You go to mod, press mod 3 times until you go to equation, then you come here, you press 1. This unknowns is for simultaneous equations. We go to degree, so our equation is a quadratic to degree 2. You come and press 2. Then our a term is 2. A is a coefficient of the square term. Hope you still remember that. If you've not watched our introduction of under introductory work quadratics, I already explained why we are putting a is that 2, and b will be -3, and c will be 4. We did that in our previous video. So our a here is 2. Okay, you press equal sign to proceed to b. B is going to be a negative of 3. Negative is there, and 3 here. Then c will be 4, positive 4 there. Then you press equal sign. So we see we have 0.75. If you try to convert to fraction, shift, and that give us 3 out of 4. Okay, then the second word x term is going to be 0.75. Still the same, 3 out of 4. So we have a repeated one. This is 3 out of 0.75, which is still going to be 3 out of 4. So that means basically, since, let us try to see if it's in. So that's actually, I think it's a bit exact. We can say that. Sorry. So we have our x. The x values are 3 out of 4. That's the first one. Then also x equals 3 out of 4. So that means if we have actually x minus 3 out of 4 giving us 0. In actually, if you have 4x minus 3 equals to 0, I think we can come to that. Okay, let us first try to see if we put that to be out of 4. This 4 would multiply. If you try to get the LCM of that, we're going to have x minus 3 out of we're going to have 4x minus 3 out of 4. If you get the LCM of x minus 3 out of 4, we're going to have here 4, then 4x there, minus 3. So but now it will multiply, because remember this, if this x is that means our factor is actually, you get the factor by taking this to the other side to and equate to 0. That means our factor is 4x minus 3. If you try to expand 4x minus 3, since it's repeated, it's the same value, so we can just repeat multiplying the bracket, and we see we're going to have here 16x squared minus here 12x, then that one, then minus 12x again, then here plus 9. Okay, so that means we are going to have something like for here we can see that if we have 16x squared minus 24x plus 9. Okay, even if you try to reduce this, it won't go back there. So actually we will see that this basically it's hard to reduce this, because maybe if you try to even if you try to complete squares, it won't work. For this case, we're just looking at collecting like terms, so we'll just let our equation to remain something like that, because we can't simplify since it's factor. Actually the factors are not actually so exact. Okay, factors, it's a repeated one, but it's a fraction, which if we try to fix it here, it's going to be harder. Unlike if we try to expand, let me say x minus 3 out of 4 into another x minus 3 out of 4. Okay, we're going to have x squared, then minus 3 out of 4x, then minus 3 out of 4x, then we have here plus 9 out of 16, which we are going to have x squared minus 6 out of 4x. Okay, then plus 9 out of 16. If you multiply throughout by let me say 16, the bigger one, you're going to still have 16x squared minus now we have here 16, which will be minus 24x, then plus 9. which will still come back here. That means that one will actually we can't simplify it further. We have already our like terms 2x squared 3 minus 3x then plus 4, which actually can't be, we can't combine those to form one term. Now let's check on another one. 4, let's say multiply out or expand the following. Okay, the following terms in brackets. Simplifying the answer where possible, so we can simplify if possible. Okay, let's check the first one. We have 3 into x plus 2. Remember when we looked at in our introductory work, we looked at expression of this form. The number outside or the term outside the bracket will multiply each term inside the bracket, and you consider the sign. For this case, that means we are going to multiply x with a number with the term outside the bracket. Then we add to also that same number outside the bracket multiply by 2. See that 3 will multiply x, and also you add then make it multiply 2 again. That means we are going to have 3x plus 6. That's our expansion. Then we check another number, say b. We're going to have another number, let me say negative 2 into x plus 2. Still, this time we're going to consider the sign x, then plus still negative 2 times 2. What does it mean? We're going to have negative 2x, then negative 2 times 2 is negative 4. We're going to have that's our expansion for that. Then we go to c. C will be now let me say negative 5 into x plus 2y minus 3. Now for this case, you observe we have 3 terms inside the bracket, so that one out will still multiply all of them. So negative 5 times x plus negative 5 times 2y minus negative 5 times negative 3. Okay, consider negative 5 times negative 3. Now there was a minus negative 5 times 3 already, because we already considered the minus here. Okay, there was that minus we already put, so it's going to be now negative 5 times only 3, since we already put the minus. So that means we're actually going to have something like negative 5 times x is going to be negative 5x. Then negative 5 times 2y is going to be negative 5 times 2 will be negative 10y. So minus 10y. Then we have negative 5 times positive 3 will be negative 15, but this minus will make it a plus of 15. Okay, so that's it for that. If you have another one, let me say, let's check about maybe for one which has maybe 2 brackets now expanding. Let us say another one, d. Let's say having x plus 1 into x plus 2. Okay, under this, when we looked at those ones of this form in our introductory work, still under quadratics and basic algebraic manipulations, we looked at this and we say each term in this first bracket multiplying this bracket. That means each term here will multiply this bracket. That means we are going to have x multiplying that bracket. Then we add 1 also multiplying that bracket. That's how we looked at it. So that we are going to have something like that one, x squared, we multiply x, then plus 2x, then plus x. If you one will multiply that and remain x plus 2 if one multiplies that bracket. And we are going to have something like x squared, 2x plus x will be 3x, then plus 2. Okay, that's our expansion for that. Then we go to e. Let's look at, let me say x minus 2 into x plus 3. For this case, remember in our previous video, when we're looking at this, we under quadratic expansions, we looked at this form when you have a bracket which has a subtraction of 2 terms and another bracket multiplying another bracket which is adding 2 terms. We just simply take we consider it to be a difference of 2 squares, in that the first term in that it's going to be the actually it's going to be for that case it will apply if actually this one are the same. Sorry, so for this case it's not a difference of two squares, since 2 and 3 are different. We had something like this, then something like this, but we realize that 2 and 3 are different, unlike here b and b. Okay, so we are just going to consider the normal way by letting x to multiply each term in the second bracket, then minus 2 multiplying the second bracket also. We're going to have x squared plus 3x, okay, minus 2x. If we multiply that, minus 6 if we multiply it, negative 2 and 3. So we are going to have x squared, 3x minus 2x will be plus x, then minus 6. So that's it. I think we can look for one more. We have x minus 4 squared. We looked at the one of the form that which we knew it was just going to be simply be a squared minus 2ab plus b squared. We looked at that expansion under quadratic identities, so we're going to just have x, that one squared, minus 2, this one is our place of a, this is a place of b, into x times negative 4, okay, into x minus 4, into x times 4 actually. Then we have here then plus 4 squared. We are trying to follow that, or you can multiply normally by multiplying the brackets separately like that. Then you consider that same condition, this term multiplying that bracket, then that term multiplying that bracket. So for this case we're going to have x squared minus 8x because of 2 times 4, then plus 16. Okay, then maybe we can look at now we go to some other review. Let's review irrationals and surds. Irrationals and surds. Okay, here we're going to basically we're going to recall the properties of rational numbers. Recall this: root a times root b is the same as root of a b, like that. Let's call this up. Remember let's call that property 1. We are recalling, we looked at this in our introductory work. Then we also remember that a out of b under the same root is the same as root of a out of root a. Root of b. This is considered as our second property. Then we had a property of a root b plus c root b is the same as a plus c root b. Okay, property 2 here, this property 3. Then another one we had when there is a minus there, minus c root b, so it's a minus c root b. Can call that property 4. So we need to recall these 4 rules, or for those 4 properties. It's going to help us when we are looking at some of the questions under this. Of which, let us check on some simple questions. Let's say some review questions. Okay, simplify a root of 45. Okay, root of 45. Now to simplify this, for us to get, we are looking forward to getting a square inside 45, of which you look at those squares which are factors of 45. Factors of 45, we have 1 and 45. Okay, we have when you multiply 45 by 1, 2 is not there, 3 is one of them. 3 multiplies 15 to give 45. 4 is not there, 5 multiplies 9 to give 45. 6 is not there, 7 is not there. 8 cannot multiply any number to give 45 also, but 9 now we go back here. That means the factors are actually this. So look for a square here. We have 9, which is a square. So it's 9 times 5 can be our best way to express 45. That's 9 times 5. Okay, which is the same as having, now we consider that property there, that first property, the same as root 9 times root 5. This is the same as saying 3 root 5, because root 9 is 3, root of 9 is 3. Okay, let's look at another one. I think those ones of that kind, let me say B, root of 24. Okay, you still look for product factors of 24, 1 and 24. We have 2 and 12. We have 3 and 4. 5 cannot be there. 6 is not there. 7 not there. 6, yeah, 6 and 2 and 6, I mean, yeah. No, 6 is there. Because 4, 6 and 4 can give 45. We have 6, 4 and 6. 7 is not there. 5 is not there. Yeah, I think we are going to go up to, we're going to come this are also. We look for a square. We have here 4 and here also. So we can express in any of these. 3 times, 3 and 4 is not there. It's not, they are not factors there. So we have only 4 and 6. So that means this can actually be expressed as 4 times 6. Apply that property 1, will say be root of 4 times root of 6. What do we have? We're going to have 2 root 6. That's how we can simplify that. So you look for the factors of that number, numbers that multiply themselves to give that number. That's what I mean. So I think we can now check on, let me say C. We have another one, 6 root 7 plus 2 root 7. We are applying we are applying that. Okay, you know that is the same as A plus B plus C into root of B. So this one is simply 2. This is plus, sorry. This is simply 2 plus 6 root 7, which is the same as 8 root 7. Okay, that one is already there, and maybe we can simplify. Let's say one more. Let me say root of 8 minus root of 3 into root of 8 plus root of 3. For this case, you know, plus here, minus, same terms. We are going to just simply use difference of two squares. 8 squared minus root of 3 squared, which is going to be here 8 minus 3, which is going to be 5. You can expand. We applied this a plus b into a minus b to be a squared minus b squared. We looked at that in our previous one when we were looking at quadratic identities. So we these examples remind us about the algebraic result for difference of two squares, this one, because when you try to check that, if you might expand that normally using this term, applying that bracket, and minus this term, applying that bracket, and you expand, you'll get still reach there. So for today we are done. See you guys next time in my video. I'll continue with still the review. I'll below where we'll proceed to rationalizing the denominator. Please don't forget to like, subscribe, and share, and see you in my next video.